All right, so here we have another question. It's a good question here. So this is another work problem. This time we're not talking about people, we're talking about pipes. Could be talking about machines too, but for now, we're talking about pipes, right? So one pipe can fill a pool in 9 hours. A second pipe can fill the same pool in 6 hours. How long will it take both pipes working together to fill 3/4 of the tank, or where this question says tank? Okay, so make a correction on your handout. So instead of tank, it should say pool. All right. So how long will it take to fill 3/4 of the pool? All right, so we're going to solve the problem the same way that we normally would have solved it if we were filling the entire pool. And we are going to factor in how this 3/4 will work. So there are two ways to do the problem. All right. What I'm thinking is to work with the 3/4 before we even begin anything. All right. All right. So it seems good if I just think about the 3/4 first. All right. So here's what I'm saying. The one pipe can fill a pool in 9 hours. So what does that mean? In this case, we want to think about what would happen for 3/4 of the pool. That's what we're trying to fill. So for A, the time we're worried about is not 9 hours, but rather 3/4, right, of times 9, which is going to be 27/4, which we are going to know is going to be 27/4 is going to be some decimal. 4 to 27 is going to go 6.75. So person A is going to be taking about 6.75 hours to fill to get the pool to the 3/4 mark, right? And now similarly, we want to find out what the second pipe is going to do. I say person, I mean pipe. The second pipe takes 6 hours to fill the entire pool. So I want to find out what's happening with 3/4 of the pool. So the B that I want is going to be 3/4 times 6. And if you have a calculator, that's going to be 3/4 times 6 is going to be 18/4. Dividing by 4 is easy because we're only going to get answers in increments of 0.25. So 4 into 18 is going to go 4, and we have an extra 4.5 basically, right? So it's going to be 4.50. Good. So now I'm good to go. I don't have to worry about my 3/4 anymore. So what I can have now, I know x over A plus x over B is equal to 1. Now I can use my formula because what am I saying? They are doing the same amount of work together, which is trying to get the 3/4 weight. And it doesn't matter, like with the bushel example, that you're doing 3/4. You just have to make sure that the time you're talking about is consistently referring to 3/4 to fit to getting the pool to be 3/4 full, right? So now what happens now, I have this, I have x over A, which is x over 6.75, plus x over 4.50 is equal to 1. So this problem is a little tricky. And so what I'm going to do now is I'm going to make life easier, and to get rid of this decimal, what I would do is I would multiply I'd multiply, right, by 100 over 100. So 100 over 100 for every fraction. Multiply by 100 over 100. This problem is a little ridiculous. 100 over 100 for both fractions, right? And that's it. Still equal to 1. I don't need to multiply the right side by anything. So what I have here is 100x over 675 is plus 100x over 450 is equal to 1. All right. Okay, so that's what I have here. All right, so that's that. And so I just multiply by 100 to get rid of a decimal right away. Okay, you could have used a different number. Now I got rid of the decimal. Now I know that I can simplify this even further. So 25 goes into every single one of these numbers in both cases. So I can simplify the fraction. So I'm trying to simplify 100 over 675. If I divide by 25, so I divide by 25, this fraction by 25, 100 divided by 25. So I'm dividing by 25, 100 by 25, and I'm dividing 675 by 25. Dividing 450 by 25, just to get my fraction simpler. So this one is going to give me 4. This one, how many quarters are in 675? Well, every quarter has $1 a quarter, so 4 quarters in $6. 4 6 is 24, and 3 more 27. So this is going to be 27. And so now I have smaller fractions, and this is going to be the same thing. 416 in here, and 218 is going to be 18. Good. So I have all these numbers. This is what I want to have. I want to simplify the fractions. This is something that, again, a middle school topic, we're simplifying fractions. And so this thing here, this complicated looking thing here just becomes 4 over 27x plus 25 of that goes 4 over 18x is equal to 1. So I got something simpler. Again, this is algebraic manipulation, all right? Fractions. So I get that. So this problem was a little bit trickier. And now that I have that, I can find an LCD of 27, 18. So I go 27, the next multiple up is going to be 54, 18, and so on. I suspect 54 is going to be a good 54 is going to be a good number that we need, right? And so this is 27, 54. Look at 18 times table, 18. The next one is going to be 36, and the next one after that is going to be 54. So I find an LCD, which is 54. So I multiply both sides by 54. Much better than multiplying by the other numbers that we had. All right. So if I do that, 27 to 54 goes 2 times, so I'm going to have 2 times 4x plus 18 to 54 is going to go 3 times, so I'm going to have 3 times 4x is equal to 54. That's going to be 8x plus 12x equals 54. 20x is equal to 54. 20x is equal to 54. And I want to divide both sides by 20. Okay. So I have 20x is equal to 54. I want to divide both sides by 20. And so I'm going to get x is equal to, if you divide that, you're going to get 2 point, use a calculator, you're going to get 2.7. Let me just calculate. All right, so 54 divided by 20 is equal to 27 over 10, which is 2.7. So together, it would take the pilots 2.7 hours to get to the 3/4 mark. I know this was a mouthful. But you know, I suggest just rewind the video and go over it little by little. The answer is indeed 2.7 hours. That's indeed correct.